Okay, so in this video we'll explore the questions of what would be the field inside a cavity of a conductor, and also what will be the charge distribution inside the walls of a cavity. So let's say this is a conductor and this is the cavity inside the conductor, and let's assume that there is some external electric field. So due to this electric field there is some charge induced on the surface of the conductor. So the question is, will there be an induced charge on the walls of the cavity as well? So to explore this question, I would like to choose a Gaussian surface completely inside the material of the conductor. So inside the material of the conductor, electric field is 0. So E bar is 0 at all points on this Gaussian surface. So if the electric field is 0 at all points on the Gaussian surface, what's the flux? Flux is also 0 because flux is given by E dot ds integral. So here I'm performing the integral over the closed surface, so I indicate that with this circle. So this is 0 because E is 0 at all points. So if the flux is 0, so the charge enclosed is also 0. This is known from Gauss law. So charge enclosed by this Gaussian surface is also 0. So there is no net charge inside this Gaussian surface. That does not mean that, it does not imply that you have no charge at all on the inner walls of the cavity. For example, so let's say this is the cavity. I may have a charge distribution something like this. Equal amounts of positive and negative charge such that the net charge inside this Gaussian surface is 0, which is consistent with this equation. But the charge density at each point on the surface is not 0, which means that the sigma, which is the charge per unit area, is not 0 at each point on the inner surface. So this is a possibility which is consistent with this result of the charge being 0, the charge enclosed by the surface being 0. So we'll see if this is the case, what happens. So if you choose 2 points A and B on the wall of the cavity, so let's say this is a positive charge and that's a negative charge, and there is field out from the positive entering into the negative charge. So now I will choose this field line, which is from A to B, to be a part of closed path ABC. So this is all part of the conductor, this is all inside the conductor. So if I perform the line integral of E dot dl along this closed path ABC, so this can be written as integral E dot dl from A to B plus integral B to C E dot dl and integral E dot dl C to A. So from the diagram you can see that there is, so we have assumed that there is some electric field from A to B. So this integral, which is E dot dl from A to B, is some non-zero value, and E dot dl from B to C, it should be 0 because the electric field inside the material of the conductor is 0. So B to C is a path that is completely inside the material of the conductor, so electric field here is 0. Similarly from C to A it is also 0. So these two terms are 0. So because this is non-zero, you will get this to be some non-zero value. So you're getting this integral of the electric field over a closed path to be non-zero, but it is a basic fact that for any electric field you get the line integral over a closed path to be 0 always, which means that there is a contradiction here. So this cannot be true, that E dot dl over the closed path ABC is not equal to 0. So this cannot be true because line integral over a closed path should always be 0. So if this is not true, it means that the electric field is 0 from A to B. So there is no field at all inside the cavity. At all points inside the cavity, the electric field is 0. So if you choose a point very close to the surface, the field at that point is given by sigma by epsilon naught when you choose a point very close to the surface, and sigma is the charge density at that point. So because the electric field is 0 everywhere, sigma by epsilon naught is also 0. So if sigma by epsilon naught is 0, so that implies that sigma is also 0. So if sigma is 0, the charge density at each point is 0. So if the charge density at each point is 0, you cannot have any charge induced on the surface. So this is how the inner wall of the cavity is going to be without any charge. So if you have the case of some positive and some negative charges, so which is where we started, there sigma is not 0 at all points. So but here we have arrived that sigma should be 0 at all points, which means that there is no charge induced on the inner walls of the cavity. So whenever you have conductor with a cavity, there is no charge induced on the inner walls of the cavity. So when there is no charge inside, so here inside the cavity there is no charge, and there is no charge induced on the inner walls of the cavity as well, and there is no electric field inside the cavity as well. So field inside the cavity is 0, charge induced on the inner walls of the cavity is also 0 when there is no charge placed inside the cavity.